So BGP protocol. BGP stands for border gateway protocol. It is an open standard protocol. Means we can configure it on Cisco devices, Juniper devices, on any other vendor devices. Okay, this is one more benefit of BGP, open standard protocol. Then it is a path vector routing protocol. It is EGP. EGP means exterior gateway protocol. Then we can say it is a path vector routing protocol. Path vector routing protocol means it uses ES for best path selection. The protocol which uses autonomous system number for the best path selection, those protocols are known as path vector protocol. Here best path selection in BGP, best path selection is done by attributes. We will discuss about the attributes later. It is a classless routing protocol. What is the meaning of classless routing protocol? Yes, very good. It support subnetting and VLSM. Then by default, you can say by default, auto summary is disabled in BGP. By default, BGP support one path in the routing table. By default, BGP does not support load balancing. So by default, maximum path that BGP can install in the routing table is 1. Maximum path is 1 by default. By default. Anything else? It uses TCP port number, port number 179. Very good. It is an no, bro. It is an application layer protocol. Layer protocol. It is a completely reliable routing protocol. Reliable routing protocol. BGP is the only reliable routing protocol, means completely reliable protocol, we can say routing protocol. Then yeah, it support manual summarization. Manual summarization. Anything else? It uses two administrative distance values, that is 20 and 200. 24 external BGP, and 200 for internal BGP. So we have two AD values in BGP. Anything else, guys, about the BGP protocol that here I can mention? No, it does not support dynamic neighborship. What you can say, it does not support supports dynamic neighborship. Yes. Anything else? It does not support dynamic neighborship. It sends their messages on unicastle base. Unicastle base. So these are the basic points about BGP. You can take one a screenshot. If anyone will ask you like what is BGP, you can tell them. Now router 1 and router 2. You know how to configure BGP. In last class we had seen the basic configuration as well. R1, I2. S number 100. Here also S number 100. So it will form which type of BGP neighborship? IBGP neighborship. Correct, guys? Am I right? So what command you will run to enable BGP on router number 1? Router BGP S number 100, then neighbor 12.1.1.2 means IP address of neighbor. Here IP address is 12.1.1.1. Here IP address is 12.1.1.2. Neighbor IP address and then remote yes. Right? Then on router number 2 again router BGP S number 100, neighbor 12.1, remote yes 100. After that both routers are going to send SYN message with the help of SYN plus ACK and ACK. Both routers are going to form TCP connection. Correct? After forming the TCP connection, on TCP connection will establish, both routers will send what? BGP messages. So the next topic is messages, types of messages in BGP. Now I am expecting you know how these two routers are going to form TCP connection. How these routers are going to form TCP. Yes, with the help of three-way handshake. And which table it will maintain to store information? TCB table. TCB, transmission control block. Transmission control block. Now guys, understand types of messages. Types of messages in BGP. First type of message is open message. Second type of message is keep alive message. Keep alive message. Third message is update message. Fourth message is notification message. Notification. And fifth message is route refresh message. Okay. Now tell me the use of hello message in OSPF. What is the use of hello message in OSPF and EIGRP? To discover the neighbor. First use is discover neighbor. Second use, keep alive. So guys, in BGP we have divided this hello message into two messages. First one is open message, second one is keep alive. Open message is used to discover the neighbor and keep alive message is used to track the neighbor, that neighbor is alive or not. So these two types of messages are clear, open message and keep alive message. Now update message. So again, update message is similar like OSPF update message or EIGRP update message, right? BGP use update message to share network information, NLRI. In BGP we called NLRI to prefixes to your subnets. Like let's say router 1 is connected with one subnet, that is 10.1.1.0/24. So what we call to this subnet, this prefix, NLRI, network layer reachability information. So BGP sends NLRI information with the help of update message. Done. The fourth type of message, that is notification message. See guys, this message is for error. For error. Whenever router 1 is going to break neighborship with router number 2. Now if you are thinking that Praful, why router 1 will break neighborship with router number 2? Guys, there are many reasons for it. Don't worry, we will see those reasons. But let's suppose there are some misconfiguration or router 1 is receiving some route from router 2 that is incorrect. Incorrect route from router number 2. So router 1 is going to break the neighborship with router number 2. But before breaking the neighborship, router 1 is going to inform to router 2 that bro, I am going to break the neighborship with you. It will also send the reason like why I am breaking the neighborship with you. Let's suppose I and you both are friend, right? We have friendship, good friendship, but because of some communication, now I want to break the friendship with you. So I will use notification message. I will send you a notification message to inform you that I am breaking friendship with you. At the same time, in that message, I will also share the reason why I am breaking neighborship with you. Done. So whenever there will be some misconfiguration or the router will receive the incorrect route, right, from their neighbor, it is going to send notification message, and after sending the notification message, router is going to break the neighborship. It will close the BGP pairing for that particular neighbor. And then guys, route refresh message. Route refresh message is used to refresh the route. See, both router 1 and router 2 have formed the BGP neighborship, right? Let's say now I have changed some policy configuration, route policy configuration on router number 1. So router 1 need to update their database. At the same time, router need to update database of router 2 as well, right? So these routers are going to refresh their database with the help of route refresh messages. If you will configure any new policy on router number 1, it will send one route refresh message to router number 2 instead of resetting the neighbor, right? Or let's say you want to manually update the BGP database, BGP table, right? Like I am running command in OSPF clear IP OSPF process to clear the OSPF process, correct? In the same way, in BGP also we can clear the process, we can break the neighborship. But guys, if routers are breaking the neighborship, that means it is using their CPU utilization. BGP is vast routing protocol who is going to manage vast number of prefixes, very large number of prefixes. So if these two routers will break the neighborship, and again form the new SIP, it will use lots of memory, lots of CPU. So that's why we have this message route refresh message. Instead of breaking new SIP, routers are going to exchange route refresh message to update their database. Whenever we will apply the policy, whenever we will modify the policy on router, don't worry about the notification message and route refresh message. You will understand more about these two types of messages. Tell me, is these three upper messages are clear to you or not? Open message to discover the neighbor, keep alive to track the neighbor, update message to share NLRI information, or you can say to share route information, network information, subnet information. Clear? Yeah. All messages are unicast in BGP, bro. All messages are unicast. TCP, BGP is a TCP based protocol. TCP does not support multicast. Always keep in mind all the protocols which are TCP based will always send their messages on unicast address. Getting my point? So these all messages are unicast message. Done. So open message, if someone will ask you what is open message, you can say it is used to form neighborship. Router will share open message only once. This is not periodic message. Only keep alive is the periodic message, and guys, size of keep alive is very less as compared to OSPF hello message, EIGRP hello message. Keep alive is very small message, right? And this message is only periodic message. Router will be exchanging only keep alive message between each other to track the neighbor. It will only send open message once to form the neighborship. Once it will form the neighborship, it will be only sending keep alive messages. Clear? Content of hello message, sorry, open message. See guys, by mistaken if I am saying hello message sometime, please consider the open message, right? There is no any hello message in BGP. Done. To check the content of open message, what I can do, I can configure BGP on both router and then I can capture the link. Here IP address is 12.1.1.1. Here IP address is 12.1.1.2. On both router, right now I am running same ES. This is my IBGP protocol. ES number is 100, and here also ES number is 100. Clear? Let me access these routers. R1, R2. See, by default, if you want to see which ports are open on the router, like BGP is using what port number? 179, but by default BGP is not enabled on the router, right? So that port is disabled. So TCP, there is one command, guys. Let me find that command. Here I can say what? TCP console, not console, sockets. Just wait, let me try. So TCP socket, no, there is no any command like that. So just wait, let me try once again. So TCP so IP source track option is there. Just Google it. What is the command to check open port on router? You can Google it. You will find that command, right? And you can run that command on router to check. Yeah. So TCP connection option is not showing here. Console option is there. So IP TCP is there. TCP. Yeah. So IP. Yes, bro. So IP. So IP socket. No. So IP TCP. You can check, there is one command like that. You can find the open port by default, and you will see only port number 23 means telnet is enabled by default on routers. Rest all ports are disabled. Okay, now let me configure this router quickly. Interface f0/0, or if you want to check the port right now, just do one thing, just Google the command. Google it, no search and IP address. Till then I am configuring IP and BGP here. 255.255.255.0 exit on router number 2 config t router interface f0/0, say no set, and IP address 12.1.1.2. command to check TCP open port on Cisco router. You can give this prompt. Now I have configured the IP. Let me verify the connectivity between R1 and R2. Ping 12.1.1.2. Ping is working, and so TCP brief. See, TCP table is empty. Now let me configure the BGP router. BGP S number 100, and before that let me capture this link also. Yeah, guys, is router sending any open message on the link? No, it will not send any message of BGP until and unless it will not form TCP connection. Even here I have not defined the neighbor command. Neighbor 12.1.1.2 and remote ES of neighbor is 100. Now you will see this router will start sending SYN message. Router will start sending SYN message. How to verify that? We can debug TCP, debug IP, TCP, debug IP TCP packet. See here, it is sending SYN message. Source port number is random port number 15236 and destination port number is well known port number of BGP. And router 2 is sending what? Reset message. Reason? This port number 179 port number is not enabled there on router number 2. So whenever your router will receive a SYN message for a particular port number and that port number is not enabled, if that port number is not enabled on the router, then in the response your router will send reset message, and same thing is happening over here, right? Even in the console also you can see router is sending SYN message. These are very helpful for troubleshooting, right? When you will troubleshoot BGP neighborship, it is sending SYN message and it is receiving reset message because BGP is not enabled on router number 2. In the SYN message, guys, SYN message, source port number is random port number, any random port number, destination port number is 179. Source IP address, the IP address of exit interface, destination IP address is neighbor IP address. Source MAC will be the MAC address of router 1, exit interface destination MAC will be the MAC address of 12.1.1.2, right? So IP ARP on all, so IP ARP. See the MAC address of 12.2. From here, from this table, router 1 will find the MAC address of 12.2. Then it will forward to router number 2. On router number 2, it will accept at layer 2, at layer 3, but at layer 4, it will discard the packet and it will send the reset message. Reason, this port number is not enabled, 179. So now what I am going to do, I am going to enable BGP on router number 2. Till then you can see router 1 is sending SYN and router 2 is sending reset. Fine. And so TCP brief, still there is no any connection. Now router 2, router BGP S number 100. I have run this command, router BGP S number 100. Now tell me, port number is enabled over here or not, guys? By running this command, will router enable the port number 179 on this router? Nope. Nothing is there. Still you can see router 1 is sending SYN and router 2 is sending reset. So until and unless we will not define the neighbor command on router number 2, it will not enable port number 179. So neighbor 12.1.1.1 and remote AS is 100. Now you can see the capturing here. Now wait for next SYN message from router number 1. See the SYN message, then SYN plus ACK message, after that acknowledgement message finally. And then are you able to see the first open message here? Now let me stop the capturing. I have stopped the capturing here. See, both routers have formed BGP neighborship. Correct? BGP neighbor. So TCP brief, TCP table. Connection is established on router number 2 also and on router number 1 also. So TCP brief. How to verify which router is using random port number and which router is using well-known port number? So 12.1 is using random port number and 12.2 is using well-known port number. Means router 1 is using random port number and router 2 is using well-known port number, that is 179. And so IP BGP summary you can see now, neighbor table. Fine. Now guys, to see the content in hello message, see, after forming TCP connection, first router 1 is sending open message. This is open message of router 1. Let me open it. This is physical layer, layer 1, then layer 2. At layer 2 you can see source MAC is the MAC address of router 1, destination MAC is the MAC address of router 2. Source IP address is 12.1.1.1, means IP address of router 1, destination IP router 2, 12.2. This is unicast message. Then this is TCP header. In the TCP header, source port is random port number, destination port is 179. And now router 1 will be using only this port number. Router 1 is not going to change this port number. Now this port number is reserved for router number 1, right? Even this is a random port number, but this port number is now reserved for the BGP on R1. And after that, at application layer, we have this actual open message of BGP. So let me open this message. See what information is there, guys. Length message type. So first information in the open message is what we can say, contents in open message. Length, message type, message type, length information, then what next information are there? Version, my AS number, version, my AS number, then hold on time and BGP identifier. BGP identifier is nothing but BGP router ID. See guys, what is the router ID of BGP on router number 1? 12.1.1.1. If you want to change the router ID, here you can configure it manually. Router BGP AS number 100 and say BGP router ID 1.1.1.1. It have resynchronized the neighborship. Neighbor goes down and then again you can say neighbor come up. On router number 2 again, router BGP AS number 100 and BGP router ID 2.2.2.2. So IP BGP summary. Now you can see again we have neighborship, right? So my AS number, then hold on time, and after that BGP identifier. Hold down time, then BGP fire means BGP router ID. Is there any other information? No. These are not for you now. Length, address family. We will discuss address family as well, don't worry. By the way, address family is nothing but the IPv4 and IPv6. So guys, these are contents of open message. Clear? Contents of open message. So router 1 and router 2, both routers are going to share these informations to their neighbor. Routers are going to share these information to their neighbor. Now here you can see in the capturing, first router 1 have sent their open message, then second open message is who is sending 12.2 to 12.1, and both are unicast. Then keep alive message. Then keep alive message. Is there any update message? No, because there is no any NLRI. There is no any network information on routers. That router need to advertise with neighbor. Then if you will open the keep alive message, like what informations are there full in the keep alive message, so you can open it. Again you can see this is unicast at layer 2, unicast at layer 3, at layer 4 source port, destination port is exactly same like open message, and then at application layer this is actual keep alive message. Is there any information? No, only message type and length. So keep alive is a very small program. Clear guys? Clear? Let me capture the link again. And now I am going to add some network here on router number 1, some LAN on router 1 and on router number 2. So let's say here I have some LAN 10.1.1.0/24 and 10.1.2.0/24. On router number 2 also I have some LAN 20.1.1.0/24 and 20.1.2.0/24. So I am going to use loopback here. Let me create two loopback. Interface loopback 1 and IP address 10.1.1.1 255.255.255.0. Interface loopback 2 IP address 10.1.2.1 255.255.255.0. Do so history. On router number 2, I'm going to change the IP address here to 2. Copy and let me paste it on R2. Done. So IP interface brief. On router number 1 also, so IP interface brief. Now how to advertise this route in BGP? Please write the command in comment section, guys. By the way, there are many ways to advertise this network in BGP, right? But yesterday we had discussed one way, one method with the help of network command, right? So can I advertise both network with the help of single command? Like router BGP S number 100. In OSPF, I can run network command like this 10.1.0.0. Can I run this network command here in BGP to advertise both subnets? No. Okay, you can say that. But you know, if you are thinking that we cannot advertise network like this just because of automatic summarization, then you are wrong, bro. The concept is whatever prefixes you are advertising in BGP, same prefix should be available in the local routing table. Same prefix, means prefix, same prefix and same subnet mask should be available in the routing table. Done. So I have to run like this. 1.0 mask 255.255.255.0 and then network 10.1.2.0 and mask 255.255.255.0. So IP BGP. See, I have advertised these two network in BGP. Now tell me, router 1 is going to send how many update message to router number 2? One update message or two update message? Router 1 will send how many update message to router number 2 to their neighbor? One update or two update for two prefix? Guys, here router 1 will send only one update message. Router is going to advertise all prefixes where routing policy is same in a single update. Like let's say router 1 have 100 number of prefixes in the BGP table. 50 have different routing policy and 50 have different routing policies, right? Then router 1 is going to generate two update messages. One update message carry those all prefixes which have same routing policies. So in this scenario, both routes, both subnets have same routing policies. So that's why router will advertise both with the help of single update message. And see here the update message in the capturing. Earlier it was sending keep alive message, keep alive, right? Once I have advertised 10.1.1.0 network in BGP, router 1 have sent the update message, right? Source IP 10.12.1, destination IP 12.2. It is unicast. Open it. At layer 2 you can see unicast, at layer 3 unicast, at layer 4 source port. Source port number is 179. Now router 1 is using source port 179. See, neighborship has resynchronized when I have configured the router ID, and that time router 1 have started using port number 179, which is well known port number for BGP source TCP brief. You can see here 12.1 is using 179 now. So source port is 179, destination port is random port number, and this is the update message. If you will open the update message, see the information. Length informations are there, types of message, total path attribute length, and after that here path attribute and then network informations. Don't worry about the path attribute like origin code, ES path, next hop, multi-exit. This is nothing but the metric, MAT, and local preference value. So router is sending two important information in the update message. One, attributes, right? So router number 2 are going to use these attribute to find best path. Guys, EIGRP sends what in the update message? EIGRP sends K1 and K3 by default, right? With the in the update message. Let's say EIGRP router is sending 10.1.1.0/24 network to their neighbor. So with this prefix, it will include K values. OSPF sent what? Cost value. Correct? OSPF sent cost value in the update message. And BGP sends attribute. Right? These are few attributes, but in BGP we have more than 12 attributes. We will discuss all attributes in the upcoming days. Right? So router 1 is sending attributes information, and after that finally what? Network layer reachability information, NLRI. As I told you, we call two prefixes in BGP NLRI, right? So if you will open it, you can see the network information 10.1.1.0/24 prefix length, NLRI prefix length, and NLRI prefix. So update message carry these informations: attributes, network information, length, and the message type. Fine. After some time I have advertised one more network, that is 10.1.2.0. so it have sent see one more update message. First update, second update. Is router 2 sending any update message, guys? No. And now again it is only exchanging keep alive messages. There is no any other message of BGP on the link, you can see. Fine guys, clear? So if I will talk about the content in the update message, content in update message, length, message type, version is not there, ES number is not there, hold on time is not there, what informations are there? Attributes and NLRI. And under NLRI there are two information. First one is NLRI prefix length, and second one is NLRI prefix. Content in update message. Now let me advertise prefixes on router number 2 and see router 1 have sent this update message to router number 2. Now router 2 is going to update their BGP table. So show IP BGP. Fine. And guys, star is what? Star means valid, and greater than sign means best. That means these subnets, these NLRI are valid as well as best. And always keep in mind, BGP only advertise those prefixes to their neighbor which are valid as well as best. BGP only advertise those prefixes to their neighbor which are valid as well as best. Sometimes you will see some prefixes are only valid, not best. So if there are some prefixes which are only valid, not best, router will not install that prefix in their routing table, as well as BGP router will not advertise that network to their neighbor. And on router number 1, so IP BGP for self-advertised prefixes, you can see next hop IP address is 0.0.0.0. And to check detailed information of neighbor, you can run command show IP BGP neighbor, right? So like here you can see the link type is internal link. How many messages it have sent, how many open message it have sent, 3. How many keep alive message it have sent, 25. How many keep alive message it have received, 25. Route refresh message, 00. Total number of messages. Update message, it have sent 2 update message and received 0 update message till now from the neighbor, right? On router number 2, so IP BGP neighbor, it have received 2 update message, but it have not sent any update message. Received 2, sent 0. Now on router number 2, router BGP yes number 100 and network 20.1.1.0, mask 255.255.255.0. Network 20.1.1.1.2.0 and mask 255.255.255.0. So IP BGP. How to identify self-advertised prefixes, guys? If I want to check only self-advertised prefixes on router number 2, what I can do? So IP BGP include 0.0.0. It will show me only self-advertised prefix. I want to see all the prefix received from 12.1.1.1. So IP BGP include 12.1.1.1. These are very useful command in real time, because in real time you will have lots of prefixes in the BGP table. So that's why in BGP we have even command to check route from a particular neighbor, like receive route or advertise route. So IP BGP neighbor and 12.1.1.1, I can say show me the all advertised route, like whatever route I have advertised to this neighbor. Or I can say show me the all received route from this neighbor, received route. Like this we can filter the output. Now I have advertised both network on router number 2 in BGP. So router have installed it in their BGP table. Now it will advertise it with their neighbor, because these are best as well as valid. So go to router number 2 and check show IP BGP. Yes, it have received these 2 prefixes. Done. And now it is going to install it in their routing table. So IP route BGP. Fine. On router number 2, so IP route BGP. Now these 2 LAN can communicate with each other. Yes or no? So open message, keep alive message and update message, these 3 messages are cleared, and hope these messages are clear to you guys. Router 2 have also, yeah, go ahead. Which metric? No, metric is one attribute in BGP. It will be not always 0, bro. So IP BGP, here you can see the metric. Metric is 0. Okay. So by default BGP advertise prefixes with metric what? 0. But I want to advertise some metric. Let's say in this scenario See, this is not real time scenario. In real time, what can be my scenario, guys? Router 1 is connected with one more router here, right? This is one ISP, this is another ISP, right? Maybe here also I am running same ES number 100, and both ISP are advertising same subnet. In this scenario, I can use matrix, right? While advertising route from router number 2 to router 1, I can set matrix 0. And while reduced advertising route from this router R3, I can add matrix, let's say 10. Automatically, this path will become best path, right? So we will use those attributes for the path manipulations, right? And for the path manipulation, all the guys, for the traffic engineering only, we have lots of attributes in BGP. And as we have lots of attributes in BGP, this is the only reason why we are using BGP in real time in the production network everywhere. Fine. Now try to understand the eBGP configuration. Now guys, here let's say ES number is 200. Configuration is very simple. On router number 1, I am not going to modify anything. On router number 2, I am going to remove BGP ES number 100 configuration. Router BGP 100, no router BGP 100, and router BGP 200. And then say neighbor 12.1.1.1 and remote ES of neighbor is 100. Then network 20.1.1.0, mask 255.255.255.0. Will neighbor SIP come up? So IP BGP summary. Neighbor is active. Why neighbor is active, guys? So TCP brief. There is no TCP connection. On router number 1, see the error message. This is notification message. Why BGP is sending notification message? Because there is misconfiguration, peer in wrong ES, right? Means neighbor belongs to wrong ES. On router number 1, you have configured neighbor 12.1.1.2 remote ES 100, and now router 1 is receiving open message from the router number 2 with ES number what? 200, right? So here I need to correct the configuration. Say router BGP ES number 100 and no neighbor 12.1.1.2 remote ES 100, and I am going to say neighbor 12.1.1.2 and remote ES is 200 this time. Now again BGP neighborship will come up. So IP BGP summary. So BGP summary. So IP BGP summary. What happened? Done. Clear? And this time, guys, so IP BGP neighbor. Which type of neighbor it is? External. Right? So we'll see the difference between iBGP and eBGP. There are some difference in the BGP behavior. Like our routers are sending some attributes in iBGP neighbor, and it is not sending some attribute to eBGP neighbor, right? So behavior depends on types of neighbor, like which attributes they are going to exchange. Like earlier we had seen local preference value in the BGP table. Let me show you the earlier BGP table. Where is the BGP table? Yes, local preference value was what? 100 for received route. See, I am on router number 1, right? And router 1 have learned this network 20 network from this neighbor, and local preference value was 100. That means that neighbor was advertising this prefix with local preference value. But now So IP BGP. So IP BGP. Is the local preference value guys for received route? 0. Local preference value is 0. That means router sends, by default router sends local preference value 100 to their iBGP neighbor, and it not send local preference value to their eBGP neighbor. Got it? So don't worry, we will see those attributes later. For now, let me discuss one very important topic of BGP, that is loop avoidance. Loop avoidance mechanism in case of BGP. Let's end one. Yeah, BGP. Is it visible? Here also you can read about notification message and route refresh message. Like notification message, see, a BGP notification message is used to signal that something was gone wrong in the BGP session between two routers. When a router detects a serious problem, it sends a notification message to other router and immediately close the BGP session. This helps in maintaining the stability of network by preventing further communication that might be based on incorrect information. Here is the example as well. Like imagine two company A, company B are connected through BGP. They exchange routing information to send traffic to each other. If company A router detect that company B router has sent incorrect or malformed data, it might be sign that something is wrong with the BGP session. To prevent any problem, company A router sends a BGP notification message to company B router and close the BGP connection. This stops potentially incorrect routing information from being used. Refresh message is there, NLRI. Yes, loop avoidance mechanism. So what it's saying, loop avoidance is crucial to ensure network stability and efficient data routing. First, loop avoidance mechanism in case of eBGP, in case of external BGP. So guys, eBGP is used for communication between different autonomous systems. Loop avoidance in eBGP is quite straightforward. Mechanism. See what is the mechanism for loop avoidance in case of eBGP. eBGP uses the AS path attribute to prevent loop. AS path attribute. AS path attribute is what? List of AS that route have crossed. Right? So AS path is a list of autonomous system number that a route has passed through. When a router receives a BGP update, it checks the AS path. If the router seen its own AS number in the AS path, it knows that the route has already been through its autonomous system, so it will discard the update to avoid loop. Have you got it? No? If no, no problem. Tell me. I'm going to make you understand here, guys. No? See here. Let's suppose I have one router here, R1. Let me reduce the pane size. Done. Router 1 is connected with any other router. Router 2 is connected with any other router. Let's say R3, then R4, and R4 is connected with another router. Let's say R5 here, like this. R5 is connected with R7, router 7, and now router 7 is, let's suppose, connected with again router number 1. This is my BGP topology. Here autonomous system number is 10. Here autonomous system number is again 10. Here autonomous system number is 20. Here autonomous system number is 30. Here autonomous number is again, let's say 30. Here autonomous system number is, let's say 40. And now guys, on this router I have one subnet that is 10.1.1.0/24. Fine. Got it? So router 1 is going to advertise this subnet 10 subnet to their neighbor, to their IBGP, to R2. R2 is IGP neighbor, correct? So router 1 will not share ES number. Router 1 will not share ES number to their IBGP neighbor. Always keep in mind this point. Whenever BGP router is advertising update to their IBGP neighbor, it will not include ES number. But when BGP router is sending update message to their eBGP neighbor, router always include ES number, right? So there will be no any ES number. It will send 10.1.1.0/24 network directly. Router 1 will update their, router 2 will update their BGP table. It will install this network in routing table. If this network is valid and best, then only it will install it in routing table, and then it will advertise to their neighbor. Router 3 is which type of neighbor? eBGP or IBGP? eBGP. So will it include ES number or not? Yes, it will include the ES number, right? So this update message is going to include ES number 10. Fine. Router 3 will also update their BGP table if route is valid and best, and then it will advertise to their neighbor, to router number 4. Which type of neighbor router 4 is of router 3? eBGP or IBGP? eBGP. So will it include ES number? Yes. So this prefix 10.1.1.0/24, and earlier ES number was 10 in the update, and it have included one more ES, that is 20. Now router 4 is also going to update their table, and then it will advertise to their neighbor. This time router 5 is IBGP neighbor, so it will not include their own ES number, right? So this prefix 10.1.1.0/24, ES number is to 10 and 20, correct? Then router 5 will advertise it to their neighbor, to router number 7. This time router 7 is eBGP neighbor, so it will include the ES number. So ES number, earlier ES number was 10 and 20 in the update. Now router 5 is going to include what? 30, right? And prefix is 10.1.1.0/24. Now router 7 will update their database, and then it will advertise to router number 1. If router 1 will accept it, that means this is a loop, right? But see why router 1 will not accept it. When router 7 will advertise it to router number 1, will it include ES number, guys? Yes, because it is eBGP neighbor. So earlier ES number was 10, 20, 30, and it is going to include 40. It will add ES number 40 here. Fine. So how many ES number are there? 1, 2, 3, 4 in the update message. Once router 1 will receive this update message, it will see their own ES number in the update message, right? ES number 10 is there. That means this update is coming from same autonomous system. Router will simply discard it. So always keep in mind, whenever router will see their own ES number in the update message, simply router will discard that. This is loop avoidance mechanism in case of eBGP. Now loop avoidance mechanism in case of IBGP. Guys, loop avoidance mechanism in IBGP is split horizon. Means never send a update message or never send a network to your IBGP which you have learned from other IBGP. So in this scenario, let's say R1, R2, R3. I have 3 router. On all router I am running ES number 100, ES number 100, ES number 100. Here I have one subnet that is 10.1.1.0/24. Here I have subnet 20.1.1.0/24. Tell me, can these two subnet communicate with each other? No. No. Reason? Router 1 is going to advertise this 10 network to their neighbor, to router number 2, but router 2 will not advertise it to their IBGP, other IBGP neighbor, because router 2 is learning this network from IBGP neighbor. So this is loop avoidance mechanism in case of IBGP. This is a split horizon, right? It will not send the network information that it have learned from IBGP to other IBGP neighbor. Got it, guys? Yeah. No, here R1 and R3 cannot communicate, bro. R1 and R3 cannot communicate. Do not send those prefixes to IBGP neighbor which you receive from their other IBGP neighbor. So let's say if I have a scenario like this, R1, R2 and R3. On all routers I am running ES number 100, right? Will loop form. Here I have one subnet, X subnet. Answer is no, loop will not form. Reason, R1 will advertise X network to R3, but R3 will not advertise to router number 2. R1 will advertise to R2, but R2 will not advertise to R3. Clear? And in eBGP, whenever router will see their on AS number in the update message, it will discard that update message. So here also you can read in the PDF. By the way, I will share those PDF as well. Loop avoidance mechanism in IBGP. IBGP used for communication within the same autonomous system. Since all routers within an AS share the same AS number, IBGP can't rely on the AS path to avoid loop. Instead, it uses a different mechanism called a split horizon rule for IBGP. And the mechanism is, in IBGP, a router does not advertise routes learned from one IGP peer to other IBGP peer within the same AS. This prevents loop to form within the AS. Here is the example of a company. Now, the next important topic can be, I have seen the messages. We have covered the basic BGP configuration. Okay, next hop self rule. Next hop self rule in BGP. Next hop rule. First in eBGP. Next hop rule in eBGP. Let me write it in different page here. Then we will say see next hop rule in case of IBGP. Done. Let's suppose I have 3 router R1, R2 and R3. R2 and R3. Here I have one subnet on router number 1, that is 10.1.1.0/24. Here AS number is 10. Here AS number is 20, and here AS number is 30. So once I will advertise this 10 subnet in BGP, what will happen? Router 1 will install this subnet in their BGP table. And what will be next hop IP address, guys? 10.1.1.0/24. Next hop IP will be what? 0.0.0.0 for self advertise prefix. Then router 1 is going to advertise it with their neighbor to router number 2. Whenever router share prefix to their eBGP neighbor, router always modify the next hop IP address. Router always modify the next hop IP address. What I am saying? Whenever a BGP router share prefix to their eBGP neighbor, it always update next hop IP address. It always update next hop IP address. Clear, guys? How it will update next hop IP address? Exit interface IP address will become next hop IP address. So let's suppose router 1 is sending an update message to share this network information, which is 10.1.1.0. Next hop will be what? Exit interface IP address 12.1.1.1, right? So router 2 will learn this network 10.1.1.0/24, and next hop IP will be 12.1.1.2. Now router 2 is going to advertise it to router number 3. Again router 2 is advertising to their eBGP neighbor. So router 2 will modify the next hop. Router 2 will modify the next hop. So here network is 10.1.1.0/24, and the next hop will be 23.1.1.2, their exit interface IP address. So router 3 is going to install it in their routing table with next hop 23.1.1.2, right? And these all next hop IP addresses are reachable, right? So they can communicate with each other, right? Two LAN on router 1 on router 1 and one on router 3, 30.1.1.0/24 can communicate with each other in this scenario. There is no any issue. But guys, in case of iBGP, next hop rule in iBGP. Again I have 3 router R1, R2, R3. Again same IP address between routers and the same LAN on router number 1. R1, R2 and R3. Now guys, rule over here is, rule in eBGP is very clear that whenever router will advertise prefix to their eBGP neighbor, it will modify the next hop IP address. But the rule is opposite in case of iBGP. Whenever router share prefix to their iBGP neighbor, router does not modify next hop IP address, and it will also not send 0.0.0 as next hop IP, right? So let's say on all routers I am running ES what 10 and 10 here. On all routers I am running what? ES number 10. Guys, router 2, see here I have one LAN first 10.1.1.0/24. So when router 1 will install this network in BGP table, once you will advertise it in BGP table, router 1 is going to install it in their BGP table like 24, and next hop will be 0.0.0 for self advertise prefix. Now router 1 is going to advertise it to router number 2. Router 2 will not share 10 network prefix to router number 3. Why it will not share? Tell me the reason. Why router 2 will not advertise this network information to router number 3? Yes, because of loop avoidance mechanism in case of IBGP, split horizon. Correct? But suppose we have break the rule. We have option to break that rule, right? We can make communication possible here between router 1 to 3, right? We can break this rule. So let's suppose we have break the rule, right? Now router 2 can advertise this network information to router number 3. Then it will share but not modify the next hop IP address. So router 1 is going to advertise this 10 network to router number 2 with what next hop? With next hop 12.1.1.1 to their exit interface IP address 10.1.1.0/24, and next hop is 12.1.1.1. Fine. Now router 2 is going to advertise it to router number 3. Router 2 will install it in their routing table 10.1.1.0/24. Next hop IP address is 12.1.1.1. Now router 2 is going to advertise it to their neighbor to router number 3. So will router 2 update next hop IP address? No. This is the next hop rule in case of IBGP. So router 2 is going to advertise 10.1.1.0/24 with what next hop? 12.1.1.1. Now on router number 3, you will see this network 10 network is only valid, not best. So router 3 will not install that in their routing table. In BGP table it will install, but with what symbol only? Star 10.1.1.0/24, and next hop IP address is 12.1.1.1. So whenever you will troubleshoot this type of issue, that you are able to see routes in the BGP table but not in the routing table, or the route is not best only valid, maybe next hop IP address is not reachable from that router. Now tell me guys, can router 3 ping to this next hop IP address? No. Then can router 3 install this network in routing table? No. Reason, next hop IP address is not reachable. So this is rule of next hop IP address in case of IBGP. First of all, we have the rule, right? You will understand how we will break that rule. For now, let's say we have break that rule. So now router 2 will advertise this network to router number 3. But the next hop is 12.1.1.1. And 12.1.1.1 is not reachable from router number 3. So 10 network 10.1.1.0/24 will be only valid, not best. That means router 3 will not install it in their routing table, and it will not advertise to their neighbor. Let's say router 3 is connected with any other router, router 4. So will router 3 advertise this network to router 4? No. Right? Doesn't matter which type of neighbor router 4 is of router 3. Maybe it is eBGP neighbor, it will not advertise because this network is not best. So let me do one thing. Let me perform one lab of these two theory. So here I'm going to delete these things. Update message, this message, and this message. Here I have one subnet. Let's say router 1. On router number 1, yes number is no problem 100. Let me stop the capturing. Here IP is 12.1. Here IP is 12.2. On router number 2, let's say my AS number is 200, and I have some more routers here guys, like router 3, router 4, and router 5. On these all routers, like on router 3, 4, 5, I am going to run same AS. Bezad, you were asking this question, that how R1, R2, and R3 will communicate. See how these routers will communicate now. I will cover each and every point, bro. Don't worry. See, on router number 5, I have, let's say, this subnet 50.1.1.0, 50.1.2.0 on router number 5. On router number 1, we have these subnets. Now this is AS number 100, 2 companies. What is happening here? Irritating me. AS number 100 and this is AS number 200. These all routers belongs to AS number 200. Let me configure the scenario very quickly. Turn off and let me turn on the devices again. Let me do one thing. Let me access these all routers. Router 1, router 2, router 3, router 4 and router 5. Notepad. R1 interface F0/0 NOSUT and IP address 12.1.1.1 255.255.255.0. Exit interface loopback 1 IP address 10.1.1.1 255.255.255.0. I am adding only one network, that is fine, right? Then router BGP AS number 100 and neighbor 12.1.1.2 and remote AS of neighbor is 200, right guys? The network 10.1.1.0 and mask 255.255.255.0. This is the configuration of router 1. Anyone have any confusion in this? And please verify the configuration. BGP router ID. Copy and I am going to paste it on router 1. So IP interface brief exclude unassign. Fine. And so IP protocol. So BGP is enabled, right? So IP BGP summary neighbor is active. Fine. Now on router number 2. On router number 2, first of all, let me configure router number 5 because on router number 5 also I am going to configure loopback. So on fast Ethernet 0/0, I will configure 45 network 45.1.1.5. Between router 4 and router 5, I will use 45 network. On loopback 1, 51. BGP AS number is going to be 200 and the router ID is going to be, let's say, 5.5.5. And neighbor IP address will be 45.1.1.4. Remote AS will be 200 and the network is 50. Copy and let me paste it on router number 5. Configure T and paste the configuration. Done. Then router 2. See, on router number 2, loopback is not required. So let me remove this configuration. On fast Ethernet 0/0, IP address is 12.1.1.2, 12.1.1.1. sorry 255 correct. Then interface f0/1, say no set here, and IP address will be 23.1.1.2, 255.255.255.0. Exit router BGPS number 200, router ID will be 2.2.2.2. Neighbor is going to be 12.1.1.1, and remote AS for this neighbor is 100. There is one more neighbor 23.1.1.3, and remote AS of this neighbor is 200. And then network command is required here. R2 configuration, copy, and let me paste on R2. Done. R3 configuration, fast Ethernet 0/0 IP address will be 23.1.1.3, and on fast Ethernet 0/1 IP address will be 34.1.1.3, and exit router BGP find neighbor IP address, neighbor IP on router number 3 23.1.1.2, and another neighbor is guys 34.1.1.4. Please verify the configuration. (3.3.3) router ID was correct now on router number 2 and on router number 5. Okay, great. Copy and let me paste it on R3. Config T and paste. Done. Then R2 done. Then on router number 4, on R4 fast Ethernet 0/0, what will be IP? 34.1.1.4, and here what will be IP? 45.1.1.4. BGPS number 200, router ID will be 4.4.4.4. Neighbor IP address 34.1.1.3 and 45.1.1.5. Correct. Copy and let me paste it on R4. There is some misconfiguration guys. There is some misconfiguration. I am getting notification message. On router number 3, we have some notification message here. You can see wrong AS number. So run section BGP. Remote AS is 100. Oh my god, on all devices I have configured incorrect remote ID 200 and 200. This is for R4. On R3, neighbor IP address 34.1.1.4, and 34.1.1. Sorry, 23.1.1.2. Remote AS 200. Router ID 3.3.3. R3. Then router 2. On router 2, I think configuration is correct. On router number 2, so run section BGP. Please verify the configuration. Is it correct? Yeah. Yes, router 1. One neighbor is eBGP, other neighbor is iBGP. Now let me verify the configuration from router number 1. So IP BGP summary. See the BGP table, neighbor table. Who is neighbor? 12.1.1.2, and there is no any issue. Fine. Neighbor is up. So IP BGP. It have installed 10 network in their BGP table. This network is self-advertised. So next hop IP address is 0.0.0. This network is valid as well as best. So it will advertise with their neighbor. Who is neighbor? Router number 2. So IP BGP summary. How many neighbor are there? 2. One 12.1.1.1 means router 1, and one is 23.1.1.3 which is router 3, right? And it have received one prefix from this neighbor from 12.1, right? And it will install that in BGP table. So IP BGP done. You can see here it have installed it, and this network is valid as well as best. Next of IP address is 12.1.1.1, correct? So it will install it in the routing table also, router BGP. It have installed it in BGP routing table. Now router 2 will advertise it with their neighbor. Now tell me guys, will router 2 advertise it to router number 3 to their iBGP neighbor? Yes or no? Technically yes bro, why not? It is receiving 10 network from their iBGP neighbor. So why it will not advertise to their eBGP neighbor? A split horizon rule means do not advertise prefixes received to iBGP to your other iBGP neighbor. But this time it is receiving from iBGP, eBGP and advertising to iBGP. So it will advertise it, right? So on router number 3 guys, so IP BGP summary, first of all verify the neighbor table. Yes, you can see it have received one route from this neighbor. So IP BGP. But see, this network is only valid, not best. Now tell me why this network is only valid, not best. Why this network is only valid, not best? If it is not best, then it will, that means it will not install it in the routing table. So IP.BGP. See, it have not installed in BGP routing table. The reason is next hop. Next hop is 12.1.1.1 and 12.1.1.1 is not reachable from here. 12.1.1.1, you can see. Got it? So what I can do here, I can configure one static route for 12 network. Let me do one thing. Let me configure a route for the next hop 12.1.1.1 IP route 12.1.1.1 255.255.255.255, and guys exit interface will be what for 12 network F0/0. Next hop will be 23.1.1.2. Now so IP BGP. Now this network is valid as well as best. Am I right? Why this is valid as well as best? Because this time next hop is reachable. You can ping to this next hop IP address. See, ping is working. Why ping is not working? Why ping is not working? Because router 1 don't have a route. When router 3 will send ICMP packet to 12.1.1.1, source IP will be what? 23.3. But on router number 1, route is not available. Doesn't matter you are able to ping this IP address or not. If route is available in the routing table, then router will install, BGP will install it in the routing table. That route, that prefix will become best in the BGP table. So IP BGP. Actually routers check, BGP checks that this next hop, this is the next hop for this network. Let me check my routing table. Is route available for this network? If yes, that means this next hop is reachable, right? And this time so IP route. You can see 2L network is there. The other option is what? I can configure any IGP protocol here. I can configure any IGP protocol, right? Between router 2 and router 3, I can configure the OSPF and I will advertise 2L network in OSPF. What will happen? Router 2 will advertise 2L network to router number 3 in the form of LSA. In the form of LSA. But now the main question is, will router 3 advertise it to router number 4? So IP BGP, guys, this network is valid as well as best. So it have installed it in the routing table. Now my question is, will R3 advertise it to router number 4 to their neighbor? So IP BGP summary. See, it is receiving one network from which neighbor? From this neighbor, right? Another neighbor is this one, but both are IBGP neighbor. Both are IBGP neighbor. So if this router is learning a route from one IBGP neighbor, it will not advertise to other IBGP neighbor. This is SP Triton rule. So you can see on router number 4, so IP BGP, there is no TAN prefix. So router 3 is not advertising, correct? In the same way, on router number 5, we have 50 subnet, so IP BGP 50 subnet. Next hop IP address 0.0.0. This is valid as well as best. So router 5 will advertise it to their IBGP neighbor to router number 4. Let me take you to R4. On R4, see the BGP table. It have learned this network from router number 5, and this is valid as well as best because next hop IP address is reachable. But router 4 will not advertise it to router number 3. Router 4 will not advertise it to router number 3. This is what? IGP loop avoidance rule, or you can say mechanism. Got it? Got it, guys? Is it clear? Hey, if you have any confusion, guys, question, please tell me. Yeah. Or we cannot ping, bro. See, to ping, to make communication between 10 and 50, we come up with a technique, a feature to break this rule. Now we have to break this rule. And the technique which we are going to use to break this rule is known as route reflector. Very important topic of BGP. Route reflector. It is used to break the IBGP loop avoidance mechanism rule. Right? And in route reflector, we have generally 3 types of router. Number 1, route reflector server. Route reflector server. And by default, all routers are okay. Wait, first of all, let me tell you about the all routers. Second router is route reflector client. Route reflector client. And third one is route reflector non-client. Non-client. If you will understand this rule, route reflector concept, that means you have understood the loop avoidance mechanism in case of IBGP. What is route reflector? Route reflector is a feature in BGP which is used to break IBGP loop avoidance mechanism rule. And there are 3 types of router in route reflector by default. Not by default, sorry. There are 3 types of router in route reflector. Extremely sorry, guys. And always keep in mind the rule of route reflector is what? Rule of route reflector is, if a server will receive prefix from their non-client, then server will not advertise to other non-client. And by default, all routers in BGP are server and their neighbors are client. Their neighbors are client. Like router 3 is what? Route reflector server and their neighbors are client. Right? In the same way, router 4 is server itself and their both neighbor are client. Done. So by default, what is happening? A server router is receiving prefix from the client, so it will not advertise to their other client. Actually, this is the rule of IBGP loop avoidance. Actually, this is the rule of IBGP loop avoidance, right? So see, if sorry, sir, their neighbor are not client, brother, their neighbor are non-client. Their neighbor are non-client, 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 and non-client. So see, if a router is receiving route from non-client, a server is receiving route from non-client, it will not advertise to non-client. No. But if server is receiving a route from the client, then it will advertise to non-client. If a server is receiving route from non-client, it will advertise to client. If a server is receiving route from client, it will advertise to client. So only in one scenario server router is not going to advertise route received from a IBGP neighbor to other IBGP neighbor if both neighbors are non-client. Is it clear? By default, all routers are server and their neighbors are non-client. So guys, in this scenario, R3 is learning 10 prefix from router number 2, but it is not advertising to router number 4. Reason, router 3 is the server router and their neighbors are non-client. So it is receiving route from non-client router. It is not advertising to other non-client neighbor. But if I can tell to router that, bro, your neighbor 23.2 means router 2 is not non-client, your this neighbor is client, then router 3 will advertise prefixes to router number 4, right? Let me show you. On router number 3, so IP BGP network is there in the 10 network is there in the BGP table, right? And this is valid as well as best, but it is not advertising to router number 4. Fine. But on router number 3, what I am going to do, see, either I can say your neighbor router 4 is client, or I can say your neighbor router 2 is client. In both scenario it will advertise, right? So what I can do, I can say router BGPS number 100, router BGPS number 100, sorry, not 100, 200, 200, and then neighbor, let's say 23.1.1.2, route reflector client, right? And how many options you have here? Only one here. On the real devices maybe you will have more options. Route reflector client. Now router 3 is receiving 10 prefix from their client neighbor, so it will advertise to their non-client neighbor. So now let me take you to R4 and see the BGP table. Done. it is advertising 10 prefix now. But again on router number 4, this prefix is not best, only valid. Reason? Next hop. Reason? Next hop. Next hop is not reachable. So here also I can configure one route, IP route 12.1.1.1 255.255.255.255 and exit interface F0/0. Next hop IP address 34.1.1.3. So IP BGP. Just wait for some time. It will send route refresh message, and now you can see this network is valid as well as best. So router 4 is going to install it in the routing table. So IP route BGP. Yes, you can see it have installed 10 network. Now tell me, will router 4 advertise this 10 network to router number 5? Again, no, because router 4 is server and their both neighbor are non-client, right? So on router number 4, either I can say router 3 is your client neighbor, or I can say router 5 is your client neighbor. So on R4, what I'm going to do, router BGP S number 200 and neighbor, let's say which neighbor, 45.1.1.5 route reflector client. Go to router 5 now and check the BGP table. So IP BGP, you can see it have installed the 10 network. But again, next hop, whenever router advertise prefix to their iBGP neighbor, it will not modify the next hop IP address, right? So this next hop, there is no route available in the routing table for this next hop IP address, right? So this is the reason this network is only valid, not best. What I can do, I can configure one default, route IP route 12.1.1.1. If you are thinking that Praful, every time why you are configuring the static route, it will be complicated in real time. Definitely, bro, in real time we will not use like this, right? I will tell you what is the solution. 255.255.255.255 exit interface F0/0. Next hop IP 45.1.1.5. Default originate. No, here default route will not work, by the way. Default route will not work in this scenario. Next hop IP address route should be available for next hop IP address except default route, right? But we have concept of default information originated in BGP. We will see it later. What is the issue? IP address is 4, sorry. So IP BGP. Now you can see 10 network is still not best. Now you can see it is best. Now one question to you. Earlier router 5 was advertising 50 prefixes to router number 4, but router 4 was not advertising to router number 3. Tell me this time, will router 4 advertise it to router number 3, guys? Yes, because this is server and I have configured this neighbor as client. So this time router 4, a server router is receiving prefix from their client neighbor, so it will advertise to their non-client neighbor. So now you can check the R3 BGP table. So IP BGP, yes, it is receiving 50 prefix as well, but again issue is next hop is not reachable. IP route 45.1.1.5 255.255.255.255 and exit interface is F0/1. Next hop IP address 34.1.1.4. So IP BGP. Now tell me router 3 will advertise it to router number 2 or not? Now you can see 50 is best, so it will install it in routing table. So IP route BGP, it have installed it routing table in the routing table. Tell me guys fast, will router 3 advertise it to router number 2? Hey, why you guys are not speaking? Is class going boring, guys? Are you getting? Definitely yes, because we have already configured this neighbor. Router 2 is your client neighbor, right? So router 3 is server receiving route from their non-client neighbor. It will advertise to their client neighbor. So on router number 2, you can check. So IP BGP 50 network is there, but not best, only valid because of next hop. So here also I can configure one route, IP route 45.1.1.5 255.255.255 exit interface F0/1 next hop IP address 23.1.1.3. So IP BGP soon it will become best. Now question is, will router 2 advertise 50 network to router number 1? Yes, definitely yes, because router 1 is their eBGP neighbor. And when router 2 will advertise 50 network to router number 1, will router 2 modify next hop, guys? Yes, right? Whenever router will advertise 50 to their eBGP neighbor, it will always modify the next hop address. So you can see 50 network become best here. So it will install it in the routing table. So IP route BGP, and then it will advertise to router number 1. So on router number 1, so IP BGP, you can see 50 network is there. And the next hop is 12.2, right? It have modified it. Fine. Is everything clear? Now can 10 network ping to 50 network? Ping 50.1.1.1 and source 10.1.1.1. Fine. So IP route for 50 network, next hop IP address is 12.2, right? And so IP ARP, you can see MAC address is there for the default gateway, right? So router 1 can forward traffic to router 2 on router number 2. So IP route for 50 network. For 50 network, what is next hop? 45.1.1.5. For 45.1.1.5, next hop 23.1.1.3. So IP ARP for 23.3, MAC address is available. Yes. So router 2 can forward traffic to router 3 on router number 3. So IP route 50 network. Yes, 50 network is there. Next hop 45.5, and for 45 network, next hop is 34.4. So IP ARP MAC address is here. It can forward traffic to router 4 on router number 4. So IP route. Okay, 50 network. Next hop 45. For 45, directly connected. But every time router is doing recursive lookup, guys, right? It will check routing table twice. And whenever router checks the routing table, it uses CPU, right? So still we have problem in the network, but these two LAN users are able to communicate with each other. Even what I can do, like router 3, router 4, router 5. These routers, router 3, so IP route. These routers have 10 network as well as 50 networks, right? So right now I am only advertising one network, but let's suppose here I have 10,000 prefixes. On router number 5 also I have 10,000 prefixes. So what we can do, we can form BGP neighborship between router 2 to router 3, router 5 directly here, right? So router 1 will advertise these prefixes to router number 2, router 2 will directly advertise to router number 5. These routers are not going to install those prefixes if these routers are, let's say, service provider routers, right? So tomorrow we will see that scenario. Okay, but make sure guys you will revise the rod reflector concept, you will revise the loop avoidance mechanism concepts, whatever concept today we have covered, right? Yeah, go ahead, why not, of course. No bro, how you can, is route available for 34 on router number 1, so how you can ping? If route is not available, then you can't ping na 34 network from router number 1. In the real scenario as well, in real scenario as well brother, your requirement will be these two LAN users should be able to communicate with each other. Why you are going to ping this network? In real time we will never ping to this network. Now guys, see here I have configured the static route. Static route. So I am going to remove the static route configuration. On order number 2, do so run section IP route. No, this one. Router 3, do so run section IP route. No to this as well as no to this. Router 4, do so run section no to this. On router number 5, now see again issue. So IP BGP 50 network is not there, correct? On order number 2, so IP BGP, so IP BGP 50 network is not there, 10 network is there only, right? Router 2 will advertise it to router number 3, so IP BGP, so IP BGP. On router number 3 you can see 10 network is not best, only valid, reason next hop. So what I can do, I can now advertise this 12 network in BGP, right? We have BGP neighborship here. I have already configured the route reflector. So if I will advertise 12 network in BGP on router number 2, then router 2 will advertise it to router 3. Router 3 will advertise it to router 4. Router 4 will advertise it to router 5. Am I right? So let me take you to router number 2 here and say router BGP AS number 200 and network 12.1.1.0 mask 255.255.255.0. So IP BGP. It have installed the 12 network, right? Now it will advertise to router number 3. So IP BGP. So now you can see 12 network is there. And if 12 network is there, then this network will become, 10 network will become best, right? On the router number 4 also, so IP BGP. Now 12 network is there in the routing table, but 12 network is what? Not best, because next hop on router number 4, from router number 4, 23 network is not reachable. So on router number 3, what I can do, I can advertise 23 network in BGP, router BGP AS number 200 and network 23.1.1.0 mask 255.255.255.0. Guys, these are still problem, right? We will not use these technique in real time because we will never advertise WAN network in BGP. These are what? These are actually WAN link, right? So we will not advertise WAN link in BGP. This is just a technique to make you understand the concept. That's it. So IP BGP. Now it have installed 23 network in the BGP table, right? So it will advertise to router number 4. Now let me take you again router 4 and see the BGP table. Now 23 network is there, correct? So as 23 network is there, now in the routing table you can see 10 network became best. On router number 5, so IP BGP 10 network is only valid, not best. Next hop 12 network is there in the routing table, but what is the issue? 12 network is not there in the routing table. Why? Why it is not advertised 12 network? 23 network, next hop is 23 and 23 is in the BGP, so it will advertise to router number 4. Just wait. Clear IP BGP starts opt-in, and so IP BGP. What happened here? On router number 5, on router number 4, 10 network is valid as well as best. So next hop IP address is again 12.1.1.1. So router 4 should advertise it to router number 5, but it is not advertising. So IP BGP neighbor 45.1.1.5 advertise route. So this router is actually advertising 12 network to router number 5. 10 network is okay, sorry, to next hop IP address is 12.1.1 and 12 network is not best, only valid because of next hop. This next hop is not reachable. You can see route is there in the BGP table, but next hop is 34.3 and 34.3 is not available on router number 5. So now I need to advertise 34 in BGP on router number 4. So on router number 4, router BGP is number 200 and network 34.1.1.0. I can say mask 255.255.255.0. Now on router number 5, so IP BGP, clear IP BGP starts opt-in. With the help of this command, actually I am sending route refresh message to neighbor. And now you can check the BGP table. Now 10 network is, guys. What happened now? 12.1 and 12.1 is still not reachable. Next hop is 23.2 and route is available for 23. Yes, route is available for 23. So IP route 23.1.1.3. Yes, now you can see 10 network is best as well as valid. So it will install it in the routing table. So IP route BGP, it have installed the 10 network. Now let's talk about the 50 network. So IP BGP. So router 5 is going to advertise 50 network to their neighbor to router number 4 on router number 4C. So IP BGP We have 50 network or not? Yes, valid as well as best. So router 4 will advertise it to router number 3. So IP BGP. But on router number 3 guys, 50 network is only valid, not best. Reason, this network, this next hop IP address. So on router number 4 I can advertise 45 network in BGP. Router BGP number 200 and I can say network 45.1.1.0 mask 255.255.255.0. Now let me take you to again R3 and clear IP BGP star soft in. So IP BGP done. Best as well as valid. So it will install it on routing table. So IP route BGP 50 network is there, done. And now it will advertise to router number 2. So IP BGP. But again on router number 2, what is the issue? Next hop 45. Route is there for 45. Yeah, 45 network is there in BGP, but next hop is not reachable. 34 network. So I think I had already advertised 34 network or not. So IP BGP 34. Okay, I got the issue here. For 45 next hop is 34.1.1.4 and for 34.1.1.4 next hop is 34.4 and 34. So IP route 34.1.1.0. route is not in table. 34 network for this network. Next hop IP is 34.1.1.4. Router BGP 200 network 34.1.1.0 mask 255.255.255. Yeah, done. So IP BGP, soon 50 network will become best. Now 45 is best. So IP route 45.1.1.0. Yeah, route is there in the table. So IP BGP. Yes, now 50 is valid as well as best. So router 2 is going to advertise to router number 1. So IP BGP. But see the size of BGP table guys, right? Unnecessary I have advertised lots of prefixes in BGP, right? So this option is also fail, not recommended. The third option and the best option that you are going to use in real time is whenever we will receive a prefix from R3, please put next hop IP address 34.1.1.3. I can manually tell to router that bro, please update the next hop IP address, right? So that was a simple, right guys? But I want you should configure like this first, and then see, now I am going to remove the BGP configuration. I will remove the network advertise command, and simply on router number 3 and on router number 4 I can still see like this. what I can do, I can say route map, let's say name Cisco, and the statement is permit, and here I can say set IP next hop IP address on router number 3. Like let's say I want to tell router 3, brother, whenever you will advertise prefixes to router number 4, please set next hop IP address 34.1.1.3, your exit interface IP address. So I am saying set IP next hop 34.1.1.3. This is the option which you will use in real time, bro. On router number 3, warning, next hop IP address is our IP address. Next hop IP address is our IP address. Okay, so here next hop IP address, let me take you to R4, not R4, on R3. Next hop IP address should be what, guys? Next hop 23.1.1.2. Don't worry, we'll configure this scenario again, right? But like this, I can set any next hop IP address, right? And now I can call this route map with neighbor in BGP. What I can do, I can say router BGP AS number 200 and then say neighbor 34.1.1.4 and route map name Cisco. That's it. Then direction out. Whenever you will advertise prefixes to this neighbor, call route map. So guys, in BGP there are multiple use of route map. Every day we are going to use route map in BGP class, right? So whenever this router will advertise any prefixes to this neighbor, it will call to this route map Cisco, right? And in this route map, now you have set what? Next hop self IP, next hop IP address. Like this, you can set the tag value, you can set the local preference value, you can set the attributes of BGP, you can add the AS number. Like let's say I want that whenever router 3 advertise prefixes to router number 4, it should add one extra AS number, that is 600, right? Simply I can add that AS number in the route map, right? I have the route map Cisco permit. Here I can say what? Set AS path. AS path prepend means add, right? I can say 600 or 6000, right? Now I can apply this route map with neighbor. This is the way how you are going to configure this scenario in real time. So now what I am expecting, you will configure this scenario by yourself, right? If you will have issue, then you can let me know, tomorrow I will configure it. If you will have any issue, then you can let me know, I will configure it. Any question, please ask.